So it's a straight binary system, it's just using current instead of voltage. The ground is used for shielding. The shield comes from the MIDI out, and the thing to notice here is that the ground of the controller and the cable never touches the control device, the sound pack. Okay? So the idea here is that you don't need a voltage reference, so you don't need a common ground. You just use this currently. The grounds never touch. So there's no way of getting a ground loop through the MIDI system, which is a very key thing. As we mentioned last week, ground loop introduces a lot of hum. You could still have that problem with the audio part of it if you're not careful, but at least you know no ground is coming through the MIDI. So it's good for that. The downside is it's very kind of kludgy. Like I said, you need two conductors. You can't have a common ground, so each cable is unidirectional. The other thing is that if you want to split or combine things, you need an active device, right? Because if you can't, like with anything with a voltage and then splitting it to two devices with high input impedance, you can just use a passive splitter. But given that it's driving current, you need something to receive the current and then drive two other output devices. Okay, so MIDI connectors. Typically you have three connectors. In is the connector that takes MIDI data. Out is the connector that spits out MIDI data. And then through is an isolated copy of in. Okay? So the advantage of this is if you had three keyboards and you want one to control the other two, you would have the out from the first one to go to the in of the second one, and then the through of the second one to go to the in of the third one. So it would give you a way to daisy chain devices. A lot of devices nowadays don't have the through, and what they'll do is they'll have an in and out, and if you're using the device as a controller, you software configure the out to be an output. If you're using the device as a sound bank, you software configure the out to be a through. So that's one way to get around it. And again, anytime you need bidirectional, like for instance, I have some equipment hooked up to my MIDI rig on my computer. In order to get bidirectional, I have to go from the out of the guitar processor to the in of my computer, and then from the out of my computer to the in of the sound processor. And so you need two cables if you do bidirectional. And they do a lot of stuff like they can transfer presets and patches and stuff over that. Modern computer software is pretty handy with the MIDI. Okay, so as I mentioned, with the physical format, anytime you want to split or combine signals, you need to have an active device. It's got to be something that terminates the one and sends a multiple. So the switchers are kind of an older technique. That's ways, it's an active way that you would configure where we take signals in and you route them signals out. And you kind of manually configure them. A merge is something that takes signals from multiple inputs and puts it to a common output. So if you've got the two-tier keyboard system, you can run those to a merge and then run one MIDI cable from there. And that's got to have some intelligence to it, right? Because if you get a MIDI command, which we'll talk about, which is like a note on command is 3 bytes. Obviously, you have to buffer that 3 bytes, and have it wait if there's another command on the other side of the merge, right?
So you can keep
right, so you keep them independent. So they each have their own channel information, but you can't, stick bits in the middle of the byte. You have to keep the integrity of the byte and of the multi-byte command. So merge gets, tricky. There used to be a company that created what they call pocket MIDI devices. They're about the size of a deck of cards, but about 2 thick. And so you can get like a little box that would do MIDI merge, like 2 in and 1 out. They did a bunch of different things. One of the nice things you can get now is patch bays. And they're real handy. The one I use is the Motu Micro Express. And the nice thing is it's got 4 inputs and 6 outputs. And then it has a USB that you can control the patches, and I think it's got like 8 positions. So you can have something where input 1 goes to all 6 outputs, or You know, inputs 1 and 2 go to outputs 2 and 1, and so you can hook up like a device bidirectionally through it, and then you can have like another keyboard control 3 other things. So you can split it, and you can make any of the 4 inputs connect to any of the 6 outputs. The only danger is you got to watch if you got feedback, because then you hit one key and it rings forever because it keeps sending the same MIDI command. Yeah, voice of experience. Okay, wireless MIDI. Somebody asked me about this, and like I said, I mentioned this device is actually a wireless MIDI controller. I didn't bring in the wireless receiver, but what it'll do is as you play, it'll send it out over 2.4 gigahertz band. I'm not sure if it's Bluetooth or not. And then the computer will receive that, and so you can sit on your couch and play into your keyboard. It's coming out of speakers, and it's nice. You don't have to worry about the cables getting tangled up. There are a number of different companies that make it. The thing I've found is that it seems that none of the companies say they work with other companies, and in some cases, why would they have to? You know, if you're going to buy a transmitter, you're going to buy a receiver, you might as well buy them from the same company. So they all work with themselves, they don't work with each other. So my guess is at this point is that the standard, there is no standard that's proprietary. So unfortunately, there's not a nice way of saying, okay, this MIDI command, converts it as BPSK or PPSK or QAM or something waveform, that they're doing something on their own. And unfortunately, it didn't really become popular until recently, which, so they probably missed their #1 usage, which would have been guitars. Because in the 80s, the guitar and the Jan Hammer and everybody would have been awesome if they could have been wireless. But I don't think that they had any. If they did, they were very small. You didn't have things like this. They had very custom. I mean, there's nothing technologically problem. So maybe the pros had them back then. I don't know. Okay, so now we'll get to MIDI data format. So we know a little bit about how to connect. We know a little about what you want to do. You want to control things with it. How does it work? What are the guts? And this is where I say that of all the technological things we cover here, this is by far the simplest. It's an incredibly simple standard. It was invented by musicians to work with musical instruments. It's not hard to understand. There are a few intricacies later, but it's nothing compared to like a modern wireless standard. I forgot to look up which year it was defined in. Like I said, I'm pretty sure it's the early 80s. They say originally it was designed for this common UART. At the time, UARTs, were standalone devices. Nowadays, you can buy a $10 microcontroller that has the programmable UART in it. The baud rate is 31250. So that's, roughly 30 kilobits per second. Very, very low data rate. Since it's a binary symbol stream, the baud rate is the same as bit rate. If you have higher modulation, the baud rate is the symbol rate, basically. So the 30 kilobits per second, is pretty sad for modern applications. And unfortunately, this has become a real issue because there are some devices like there's some of the older drum machine brains, right? Drum machine brain is the MIDI-controlled sound bank you hook up to a rack of drum pads for an electronic drum kit. And some of them would allow you to download samples. But if they didn't have something like USB or a modern computer interface, the only way to do that would be a MIDI. So you can imagine, downloading audio samples at 30 kilobits, it was kind of started and let it go and come back to it 3 hours later. It's
power for a snare.
it's brutal. In fact, this one drum, that's what I have an older brain. It was, pro quality, but they never got that computer interface going. So I have a library of sounds that I'd love to try because the default sounds aren't so great, but I've just never had the time to sit there and set it up and let it go. So the basic format for this thing is very simple. It's like you think about RS-232, you have start bits, stop bits, all that.